Good morning, dear friends. Today's topic is gated recurrent unit. It is a part of recurrent neural network. It is advanced version architecture or version of recurrent neural network. A gated recurrent unit is a recurrent neural network that is a part of the deep learning model and architecture designed for processing sequential data such as text, speech, time series, and sensor signal. This this architecture model is introduced in 2014. It is uses gating mechanism to control how information is retained and update over time, helping mitigate the vanishing gradient problems that limited earlier recurrent network. It is widely used because it often achieves performance comparable to more complex architectures while requiring fewer parameters. This is a diagram of gated recurrent units. नीचे what is sequential data? Sequential data is data arranged in sequence where order matter. It is a descending order or ascending order. Data points are dependent on other points in this sequence. Example of sequential data include customer grocery purchase, patient medical records, or simply a sequence of number with a pattern. Background: gated recurrent units was proposed by Kainom, Shaw, and a collaborator as a simplified alternative to long short-term LSTM memory networks. The design reduces the number of gates and internal state compared with the LSTM, making training and inference computationally lighter while preserving the ability to learn long-range dependency in sequential data. It can handle huge volumes of sequential data which cannot be compiled by recurrent neural networks. How it works? How GRE works? Recurrent unit maintains a hidden state that acts as a network memory. Two gates cover information flow. The update gate, which determines how much past information should be carried forward. The reset gate, which control how much previous context should influence the current computation. These mechanisms allow the model to selectively remember important pattern and discard irrelevant history. That means which data is not relevant for any purpose, any parameters, then this kind of data has been removed by the GRU. Strength and trade-off. The main advantage of GRU is the balance between the model capacity and efficiency because they have fewer parameters than LSTDM, long short-term memory. They typically train faster and require less memory. However, in some tasks involving extremely long-term dependency or highly complex temporal structure, LSTM or modern attendance-based architecture may outperform them. Performance difference often depends on dataset size, sequence length, and task characteristics. Application and impact. GRU has been used extensively in machine translation, speech recognition, language modeling, for weather forecasting, financial forecasting, anomaly detection in cybersecurity, time series prediction. Before the rise of transformer-based model, GRU and LSTM were among the dominant architecture for sequence learning. Even today, GRU remain valuable in resource-constrained environment, real-time systems. Application where recurrent processing offer efficiency advantage over large attention-based model. Related concept. GRU belongs to the border family of the recurrent neural networks and is closely connected with concept of the recurrent neural network. Long short-term memory, vanishing gradient problems, attention mechanism. Together, these ideas form much of the foundation of modern sequence modeling and natural language processing. Gradient recurrent unit also used for number of applications which can solve the problem immediately and use less number of resources of the systems. It is a very important. Have any question regarding GRU? You can send the question in comment box, and please subscribe the channel and share the channel. Thank you.